Hey, good morning, guys. My wife threw me a little challenge today. She said that the hose on our central vacuum system doesn't seem to be working. More specifically, this little switch here, it should control the vacuum where you turn it on and the vacuum comes on, and flick the switch off and the vacuum should shut off. In our system, it's constantly on. Now, this is occurring with the background of the system being a little bit unreliable. You'd plug the hose into the wall and sometimes it would work and sometimes not. You have to fiddle with it. So let's take it apart, see if we can figure out how this system works, and see if we can fix it. Well, in my experience, the control system for these vacuum systems all pretty much work the same way. The control circuit is powered by about 24 volts of AC voltage. I think they use AC because there's less voltage drop over the long, thin wires. And you can see there's two spring-loaded contacts, one there and one there. And when the contact is made between those points, the vacuum system should turn on. If you've got a basic system, you may not have a switch. And if you have no switch, then you'll have a simple round plate here. And problems with contacts would likely be right here in this situation. But we have a switch, and so we have two half-moon shaped plates where one contact makes contact on this side and the other makes contact on this side. There are two wires, one here and one here, that come along the ribs of the hose all the way up to the top. Let me show you how that works. I'm going to press this little tab in and slide this connector piece off so you can have a look at that. Now, of course, you may or may not need to do this, but if you detected infinite resistance here despite the switch, then you'd be looking for a broken wire. And to look further, you slide this screwdriver under here, and these two parts will come apart. You see how they dovetail. And here are the wires. There's the one. And then there's the other wire. And what you could easily do is you could put your ohmmeter on each end and see if the switch is functional. This seems to be fine at this end. So let's go to the other end and see what's happening where the moving parts are. Okay, now here's the handle. And one of the first things you'll notice about the handle is you can spin it completely around. And so that's an interesting thing. It means there's some kind of contact inside. Here's the switch. And in the situation where the switch doesn't seem to work, the most logical thing is to go right at the switch and see if it's working. So I'm going to undo this one Phillips head screw, and we'll take that apart and see what we see. There we are. And then what happens is this whole handle comes off. Now let's slide the switch through the opening so the handle's out of our way. Okay, I've got the head off, and the first thing I noticed was this. There's electrician's tape that's on here. And that electrician's tape is a bit of a warning sign because almost no professional electricians use electrician's tape, and it's almost never used in the factory. And so it suggests that this has been a part. Now, what I do when I test a switch is I like to have the switch completely disconnected from the system, but this is a soldered connection here. And so I'm going to try and test it with the switch in place. Now, I put myself at risk for two problems. The first is that when I test a switch with an ohmmeter, I am putting a small voltage across that switch. And so what it means is that there's a higher chance of damaging sensitive electronics downstream. And of course, the second thing is that if I get low resistance, I don't know if the low resistance is occurring inside the switch or whether it's occurring in some other area. But in any case, as a screening test, let's just check this. So we're going to check for resistance. And I've got 0.8 ohms with the switch closed. And with the switch open, I've got infinite resistance. So I know my switch is working fine. Where's the problem? Let's undo this electrician's tape and see what we see underneath it. Okay, now the tape is off, and you can see that there are two contacts that ride in drums down below. And when I pull this apart here, it all comes apart. And so here we've got some moving contacts. Now, moving contacts are by far the most likely culprit when it comes to bad electrical connections or shorts. And you notice that if this thing had moved in and out, I might have had a bad connection that might not have been seen. In point of fact, by removing the tape, I may have destroyed some of my evidence. But in any case, let's take this apart further. I'm going to press in on this plastic tab here, this one right here, and then there's one in the back, and we're going to slide this plastic piece off and get a better look at this. Okay, now once you get this unsnapped here, then the handle part, which is right here, comes right off. And you get a good view of the electrical contacts, these two drums where this contact spins. Now, off camera, I just cleaned this up dramatically, and suffice to say that there's a huge amount of dust and debris around the area. I used electrical contact cleaner, this stuff here, together with some emery cloth to clean off the contacts. And so now what I'm going to do is I'm going to put it all back together again, and we'll see if it works. Now, I am a bit embarrassed to tell you that I am using electrician's tape again as before. If you notice here, there's a tiny male prong from the handle that goes through that little circuit board to help center it. And I'm just using the tape to hold it down on that male part. Now, it did occur to me that perhaps the solder connections are worn through, and that's where my short has occurred. But there's just plastic on the other side, so I'm not seeing an obvious area where the short was. But it does seem to be centered properly now with the contacts over those two drums. It rotates nicely. So we're just going to put it back together again and see if it works. Well, I've put it all back together again, and with the switch off, I get infinite resistance, and with switch on, I get 10 ohms. So let's see if we get vacuum. Well, it looks like we got a fix. It always surprises me. With a few simple tools and a multimeter and a little common sense, you can fix almost anything. Say, if this video helped you out and you want to see more of them, hit like or subscribe or leave a comment. I'd love to hear what others say. Thanks for watching.